Hi, I'm Mr. Troha. We're going to be talking about asteroids and meteors for this lesson. So, asteroids and meteors, we think about the solar system, and sometimes you see a picture of the asteroid belt and you think that there's just asteroids all over the place and it's really crowded. And there actually are a lot. This little diagram shows how many asteroids that are a certain size. So we have 25 million asteroids that are within 100 meters. That's the size of a football field. And as we get larger and larger, we have one that is 900 kilometers. That's bigger than Texas. So let's look at this. Is it crowded really? The majority of asteroids are in between Mars and Jupiter. So if we look at the area between Mars and Jupiter, I'm not going to go through the math, but you can pause and look at it later if you want. What about the volume? Since it is three-dimensional, let's assume that all these asteroids are in that space where Jupiter, about the size of Jupiter. Look at this. That's how much volume. 264, and all of these zeros cubic kilometers. Now, let's assume we have 100 million asteroids, which is not quite that many, but it's easy to use that. So that would mean that every asteroid has 2.64 times 10 to the 15 cubic kilometers to exist in, which is a huge space. In fact, if we look at that, the average distance from one asteroid to the other would be about 140,000 kilometers, which means that's about a third of the distance of the moon. So if you were out in the asteroid belt, it would be likely that there would be maybe 3 asteroids on average, between here and the moon. So even though they always have some of these movies where they're running into asteroids all over the place, that's not really very accurate. So let's talk about asteroids. There's no real true formal definition, but they tend to refer to things that are approximately 1 kilometer in diameter up to very large, that 900 kilometer one. And sometimes they can be referred to as planetoids or maybe small solar system objects, SSSOs. I also want to talk about these terms here: meteoroids, meteors, and meteorites. And so what's the difference between the three? You can even see this animation here too. A meteoroid is when it's in space, still flying through the air. It's usually given the name of very small particles, sand or boulder-sized debris, and they can be rocky or they can be metallic. It really depends. A lot of these come from when asteroids collide with each other, and so they're very broken from different parts of the asteroid. When it enters the Earth's atmosphere and is flying through the air like these pictures here, and right at this point, then it's called a meteor. But once it lands on the surface of the Earth and it's on the ground, it's a meteorite. Now we've talked about differentiation before, and I've even had a couple questions on it in the homework. But it's this idea that when material accretes, that's clumps together and it's hot, there's the opportunity for the more dense material to go towards the center, and the less dense material is then towards the outside. Now, why is this important now? The idea is that when these planetesimals or these asteroids collide, they break apart, and depending which part ends up landing on Earth, we're going to see different compositions. So what are the different compositions? Well, when we're naming asteroids and meteoroids, which are out in space, there are 3 main types. There's the C-type. The C-type is rocky, but it also has carbon compounds in it. There's a C. There's an S-type, which is a silicate. Think of silicon. And so those do not have the carbon compounds. And then there's a metallic type, which has think of that as the core, which is going to be your iron and your nickel. Now when they land on the ground, they become meteorites, and those different types of meteoroids and asteroids match up to types of and classifications of meteorites. So there are stony meteorites. These are coming from C-type or S-type asteroids, and these are going to be the more common. You can imagine that the core is much smaller, so there aren't as many of those. In the core, we're going to have our iron meteorites. That's about 2 to 3%. They're from M-type asteroids, the metallic type. And then you have stony iron meteorites, which are only 1%, and they're usually from unusual types. Now, interestingly, even though the iron types make up only 2 to 3% of all the asteroids or all the right? So they make up 40% of all the things that we find on Earth. So why is that? Why, if they are such a small percentage, is it so much easier to find? Well, if you think about it, it's iron, and we have a tool that can find iron easier, metallic. The other place that we end up finding these asteroids, interestingly, is Antarctica. Antarctica is this hotbed of finding meteorites. Now, why is that? Notice here on the picture on the left, they just look like rocks. If we're just, they fall to the ground, it's pretty hard to tell. But in Antarctica, when it's just snow, all of a sudden you find something that's different, and it's a meteorite. Now I want to talk about some very special meteorites called chondrites. These are interesting because they're coming from, they did not go through differentiation, and so they're coming from areas from the very beginnings of the solar system. They never accreted into a larger body. They never went to that differentiation, and so all these particles are all dispersed throughout the rock. And what's amazing about these is they are leftover material from the very beginnings of the solar system. They actually have it's space dust that's all from the original solar nebula that is all put together there, which is pretty cool. They also have some organic compounds and things that we may have landed on Earth if these types of rocks hit Earth, and that may have been how life started here. So I want to talk a second about meteor showers. Of course, you always have a chance of seeing a meteor or a random meteor coming through, but meteor showers are some special time periods where the Earth is passing into a stream of cosmic dust that is sometimes left over by a passing comet. During these showers, you can sometimes see as many as 100 meteors an hour. Usually it's down closer to 30 or 50 an hour would be amazing as well. You're actually more likely to see meteors after midnight, and so the meteor showers are definitely better to look at after midnight if you're up to watch those. As the Earth orbits and rotates, the part of the Earth that's pointing towards the sun is tilted towards the sun. That's the part that's moving forward, and so it runs into the meteors. And so after midnight, that part of the Earth is actually running straight into the dust and debris. In the earlier parts of the evening, we're on kind of the backside of the Earth that is not running into those. So this link down here, International Meteor Organization, is a place you can go where you can actually get the time periods of when are these meteor showers and when are they going to be reaching their height. So last little reminder, I know those three words, meteoroid, meteor, and meteorite, can be tricky to remember, but there's the last little animation for you. Okay, thank you very much for your time.